Hello students. Hello and welcome to this video. In this video, we will solve question number 141 to 150 of binomial theorems. The link to download the PDF will be in the description, as well as at the end I will show you how you can download the updated copy and maintain it from my website and the question answer website, which I have prepared for you to ask questions to me. So without further ado, let's get started. Question 141 says that if E is equal to 6 times square root of 6 plus 14 to the power 2n plus 1 and f be fractional part of E, then prove that EF is equal to 20 to the power 2n plus 1. So we are given this expression. So this is equal to greatest integral function of E plus f. Now we let f dash is equal to 6 square root of 6 times square root of 6 minus 14 to the power 2n plus 1, which will be equal to 20 to the power 2n plus 1 upon 6 square root of 6 plus 14 raised to the power 2n plus 1. Now E minus f prime will be 2n c1 6 square root of 6 to the power 2n times 14 plus 2n plus 3 C3 6 square root of 6 to the power 2n minus 2 times 14 to the power 3 and so on, which will be an even number. Now from this we have got f minus f prime is equal to an even number minus the greatest integral function of E, which is an integer. But we know that f and f prime both lie between 0 and 1. So f minus f prime will lie between minus 1 and 1. Therefore, f minus f prime is 0. That is, f is equal to f prime. Therefore, EF is equal to EF prime, that is 20 to the power 2n plus 1. Question 142 says that find the digits at units, tens, and hundreds place of the number 17 to the power 256. So 17 squared is 289. So power will be half, here 128. And 289 is nothing but 290 minus 1 to the power 128, which is equal to C0 290 to the power 128 minus C1 290 to the power 127 and so on up to minus 1 times 128 C 128. Okay. Not 128 C 128 minus 1 to the power 128, and here n will be 128. So that is 128 C 128. Clearly, all the terms except last term would be a multiple of 10. So at units place, last term will occur, which is 1. Similarly, for tens place, only second last term will matter, which is C 127 times 290, which is equal to minus 128 times 290, that is 37,120. This is a negative term and the highest term is positive and multiples of 100, so tens place will be 10 minus 2 is equal to 8. Similarly, for hundreds place, third last term will matter, which is C 126 times 290 squared, which is equal to this much. And thus the digit will be 6 after adjusting with second last term. So that is the answer. Question 143 says that show that for n greater than or equal to 3, n to the power n plus 1 greater than n plus 1 to the power n for all n in positive set of positive integers. A backslash is missing here. It should be the symbol. Okay. So we have to prove this. Now this is essentially we have to prove that n greater than 1 plus 1 upon n to the power n. We expand the binomial expression, we get 1 plus n into 1 upon n plus n times n minus 1 upon 2 factorial times 1 upon n square, and so on. So this we can write as 1 plus 1 plus 1 upon 2 factorial, 1 minus 1 upon n plus 1 upon 3 factorial, 1 minus 1 upon n times 1 minus 2 upon n, and so on. So this essentially becomes 1 plus 1 plus 1 upon 2 factorial plus 1 upon 3 factorial and so on up to 1 upon n factorial. This is less than that. And this expression is less than 1 plus 1 plus 1 upon 2 plus 1 upon 2 factorial and so on up to 1 upon 2 to the power n. And this expression is equal to 1 plus 2 times 1 minus 1 upon 2 to the power n is equal to 3 minus 1 upon 2 to the power n minus 1, which is less than 3. Now we have been given that n greater than equal to 3, and hence n to the power n plus 1 is greater than n plus 1 to the power n. So not a simple problem, because we have to figure out a lot on this problem, that this expansion you have to figure that is less than this, and this expansion is less than this. So it's a difficult problem as such, because you have to add a lot of stuff from your own side. Question 144 says that, so that 2 less than 1 plus 1 to the power n less than 3 for all n in natural numbers. We have to prove that q less than 1 plus 1 upon n to the power n less than 3 for all n natural numbers. So proceeding like previous problem, if you see this problem, then you will quickly realize that this is 1 plus 1 to the power n. So we are computing 1 plus 1 to the power n. Now this is less than 3 but greater than 2 as well. So we have got 2 greater than equal to 1 plus 1 upon n to the power n less than 3. So it's just an exact copy of question 143 conceptually. Question 145 says that, show that 1992 to the power 1998 minus 1955 to the power 1998 minus 1938 to the power 1998 plus 1901 to the power 1998 is divisible by 1998. So we rewrite this as 1992 to the power 1998 minus 1955. So we pair these two terms and we pair these two terms. Now we know that a to the power n minus b to the power n is divisible by a minus b. Thus the given expression is divisible by 37. Because the difference between base over here is 37, the difference between base over here is 37. Now we rewrite this again as 1992 minus 1931 and 1955 minus 1901, which is divisible by 54. Now 37 is a prime number, so there will be no common factor with 54. Hence the given expression is divisible by 37 times 54 is equal to 1998. So it requires a bit of critical thinking. It is moderately difficult, but it's not very difficult problem. If you grasp it, it's very easy. Question 146 says that, show that 53 to the power 53 minus 32 to the power 33 is divisible by 10. So we write 53 as 50 plus 3 to the power 53, which is 50k plus 3 to the power 53. And 33 to the power 33 is equal to 30 plus 3 to the power 33, which is 30k plus 3 to the power 33. So if the difference 3 to the power 53 minus 3 to the power 33 is divisible by 10, then our proof will be complete. We observe the powers of 3. 3 to the power 1 is equal to 3, 3 square is equal to 9, 3 cube is equal to 27, 3 to the power 4 is equal to 81, and then 43. So it repeats in the fashion of 3971, 3971 as far as last digit is concerned. Now 53 is 4 times 13 plus 1, and 33 is equal to 4 times 8 plus 1. So the last digit for both will be same, that is 9, hence the given difference is divisible by 10. So this also requires a bit of critical thinking, non-trivial problem. Question 147 says that, let k and n be positive integers and sk is equal to 1 upon 1 to the power k plus 2 to the power k plus so on up to n to the power k. Show that m plus 1 c s1 plus m plus 2 c s2 m plus 1 c2 s2 plus m plus and so on up to m plus 1. There should be dots here. M plus 1 cm sm is equal to n plus 1 to the power m plus 1 minus n minus 1. So we see that 1 plus x to the power m plus 1 is equal to m plus 1 c0 plus m plus 1 c1x plus m plus 1 c2x square and so on. Now 1 plus x to the power m plus 1 minus x to the power m plus 1 is equal to m plus 1 c1x plus m plus 1 c2x square and so on. Now putting x is equal to 1 to 3 and up to n, we get the desired result. So question 148 says that sigma is equal to 1 to power k and followed by sigma k is equal to 1 to the power n. nck times nci, where I is less than equal to k. That's what we have to find. So we expand it for I is equal to 1. We get nck times kc1 plus nck times kc2 plus nck times kc3 up to nck times kck. Now what we do here is, now we expand along k. That is, both the terms will expand, right? So we get here, first we put k is equal to 1. We get nc1 1 times 1c1 plus nc2. So we put k is equal to 2. So this becomes nc2 plus 2c1. So this term only, the first term here, expands into this. Okay. And the second term then expands into this, and so on. So we have this series which we write as nc1 1c1 plus 1c0 minus nc1 1c0. So we add this 1c0 and this term, add and subtract. Now nc2 is equal to c0 square plus c1 square plus c2 square minus nc2 c0 square. And now let me check, this is not square. This is 2c0 plus 2c1 plus 2c2. And we add and subtract 2c0. And similarly for nc3, we add and subtract kc0. And you go on doing computation like this, you'll finally end at 3 to the power n minus 2 to the power n. So I expect you to read the result and understand. If you have problem understanding this, let me know, and I will further expand this summation and all that in more steps. Question 149 says that prove that sigma r is equal to 0 to the power n minus 1 to the power r and cr. Let NCR 1 plus r log times log of 10 with base e upon 1 plus log of 10 to the power n with base e whole to the power r is equal to 0. So the equality will hold for positive n but not for n is equal to 0, for which left hand side is equal to 1. Now we are given this, so that is effectively equal to, we split this into two terms. Okay, so this is the first part where 1 is written and then r is written over here. Okay, so r and cr is equal to n minus 1 cr minus 1 times n log 10 upon 1 plus log 10 to the power n whole to the power r. Log e is not written, that is implicit. The base e is not written. Now this is equal to 1 plus sigma r is equal to 1 to n minus 1 cr plus n minus 1 cr minus 1 1 upon 1 plus log 10 to the power n to the power r plus minus 1 to the power n 1 upon 1 plus log to the power 10 to the power n to the power r minus sigma r is equal to 0 to n minus 1 to the power r n minus 1 cr and log 10 to the power n upon this. Okay, and then we go on solving this, and we can look at the solution here and pause the video, and you will finally see that it is equal to 0. So if you are confused about any of the steps, let me know and I will further expand that. Question 150 says that find the remainder of 32 to the power 32 to the power 32 is divided by 7. So 32 to the power 32 is equal to 2 to the power 160 because 32 is 2 to the power 5. So 3 minus 1 to the power 160, that is 3m plus 1. Now 32 to the power 32 to the power 32 becomes 32 to the power 3m plus 1, which is equal to 2 to the power, there is something wrong here. Let me think. No, it's fine. So 2 to the power 3 times 5m plus 1 times 2 square, which is 23 times 8 to the power 5m, which is equal to 32 times 1 plus 7 to the power 5m, which is equal to 32 times 1 plus 7k. So this is equal to 4 plus 28 plus 7 into 32k, which is 4 plus 7r. Thus the remainder would be score. And with this, we come to the end of 150 problems. And now I will show you the website. So the website is astrotalk.org, and you can download algebra, trigonometry, and coordinate geometry books from second, third, and fourth links. Note that the downloaded PDF will not have the date, so you can add this date to the downloaded PDF, so that when you come back after 15 or 30 days and you see the PDF is updated, then you download the PDF again and add the new date. Okay, I cannot add the PDF date to the file itself because it will make all existing links invalid. Also, if you want to ask questions, you can click the X link or come directly to kandika.astrotalk.org and make a login here. You can ask questions related to algebra, calculus, geometry, coordinate geometry, mathematics, and trigonometry, probability. So if you are asking questions to algebra, make use of algebra tag as well as mathematics. Or if your question does not belong to algebra, calculus, and all these tags, then use the generic term mathematics. So you'll need to make a login and ask questions to me, and I'll be more than happy to answer your questions. And the idea is to build a community where people answer each other's questions. So with this, I will end this video here, and I will see you in the next video with 10 more problems, that is question 151 to 160. So thanks a lot for watching the video. Have a great day ahead, keep learning, and most importantly, enjoy.